In this lesson, we're going to talk about enumerations, or rather enums as they're known in C#. And an enumeration or an enum is just a special data type. So it's a data type like any other, string, integer, except, first of all, you create it yourself. And then secondly, it's different in so much that it can be restricted to a certain number of values, possible values. So an integer can store from negative billion or trillion, I forget what the number is, to positive billion or trillion or something along those lines. Many different values. Strings can be set to almost an infinite number of combinations or possibilities. But enumerations will restrict the value of the variable defined as that particular data type, that enum that you create, to just the options that you decide you need for your application. So let me give a quick example. Say we're creating an application that we want to collect information about pet ownership. And we want to create a pet class and capture the name of the pet, the age of the pet, and the type of pet. The type of pet might be a dog, a cat, a fish, and or an elephant. Okay, so now I create an enumeration called pet type, and it can only be one of those 4 different types of pets. And so when I create the pet type public property on my pet class, and I make that public property of type pet type, now I can restrict that option to only those 4 values. And it might not become obvious at this moment why you'd want to do that. After all, you might be thinking to yourself, oh my goodness, you're constricting the possibilities. What if somebody has a zebra? Or what if somebody has an eel as a pet? Well, yes, that's a possibility, but then you would just modify your code to accept those types of pets in that particular example. So enumerations are used all over the place in the .NET Framework class library. And why are they used? Because they limit the possible values that you can pass into methods. If the creators of the .NET Framework class library allowed you to pass any value you wanted to into a given method, you're probably going to see a lot more errors in your code whenever you go to run it, because it's the high possibility that you're going to fat finger the entry, and they may only be looking for one of several different values, and you provide some crazy value out of the blue, or it's not obvious to you what the value needs to be. At least, as you'll come to see, IntelliSense will lead you to what the possible values are, and so it's going to make your code more solid as a result. So don't think of constraining or constrainment inside of software development as a bad thing. It's actually a great thing. It helps you to write error-free code, at least more often. And so you'll see an example of this as we create our little code example for today. If you take a look, I've created a new project called CSASP_053, and I have a default.aspx page already created. I created a text box called hero name text box, a drop-down list box called hero type drop-down list, and then a button. I didn't really give it a name. It's button 1, and then a result label like we've been doing many times. And if you take a look at the code behind, this is where we're going to do the majority of our work. The first thing that I want to do is define a really simple class. In fact, I think I already have it on my clipboard here. I'm going to paste it in. Yeah, I created a character class, and it has 2 public properties, a name property and a type property. Now notice that in this first scenario, type is just a string. And so you can type anything you want to in the type of character. So what my intent for this property is to be used for the type of the fighter is or type of the character is a fighter, is a wizard, is a thief, is a druid, is a paladin, or a monster. And we want to use those values to determine what kind of character it is, and we might change up our code logic based on the type of character. If it's a fighter, we would use a sword. If it's a wizard, we use a wand, things of that nature. Okay, so what I want to do now is create an instance of a character and fill up their 2 properties, name and type. And pause the video if you need to catch up. I'm not going to type all this in. And so this is, we're setting the name here and the type as fighter. And then what I want to do is add another chunk of code here that's going to evaluate the type, and we'll perform some logic in our code based on the hero's type. And if the hero is a fighter, then we'll print out a simple message to our result label. Our hero is a fighter. All right, now you might be keenly have seen that I fat fingered what I typed in here, the word fighter. And as a result of that, we're not going to get the results that we would expect or hope. As you can see, there's nothing in the result label here at all. Why not? I thought our hero was of type fighter. Oh, wait a minute. I missed. Let me stop. I missed the letter I. And now if we rerun the application, you can see that we'll get the results that we expected. So this is the challenge of working with what I call, or what are known as, magic strings. Magic strings are evil in software development. You should not rely on evaluation of magic strings because you'll frequently find that the data is bad, that whether the data entry was fat-fingered or it's outside of the boundary of what you would expect the input to be. And this is where I said a moment ago, constraints are good in software development because they force you to write correct code by limiting all possible options. So let's move on from there, now that we've seen an example of how this works, and let's fix this problem and make our code more solid by adding an enumeration, or an enum. And an enum is simply a special kind of class. And as you can see here, and you compare these two chunks of code, that the character has the class keyword where an enum has the enum keyword. All right, and you'll notice that between the opening and closing curly braces, I've typed 3 values: wizard, fighter, monster. And those are the only 3 values that can be used for any variable of type character type. Notice that I use a comma to separate the different values, the different possible values, and they all must be on a separate line of your code. Okay, so now that we've done that, let's go ahead and change our character's type property to character type. Now, let me say this. If you see other people's code, you might often see something like this, where the name of the property is the same as the enumeration. That's okay. That's valid C# right there. And you'll probably want to wind up using that yourself because character type adequately describes what your intent for this property is. Just using the word type might be less descriptive. However, the C# compiler can understand the difference between a type and an identifier that you're using, a variable name or a property name. So don't worry, don't fret about using that, the same terms. You can do that, it's valid, and sometimes I guess it would be encouraged. Okay, but now that I've changed the data type of the type property, we go back up to our page load event, and you'll notice that we have some issues because we're still setting the type property to magic strings. So to remedy this, what we're going to do is use the enumeration and set the value to one of several predefined options. The hero type can only be of character type .fighter, .monster, or .wizard. So in this case, I'm going to create a fighter. And notice how IntelliSense forced us down a certain path to only choose one of those 3 options. Now, I could try to misspell this, but when I do that, I'm going to get a compilation error instead of a runtime error. And compilation errors are great because that means you, the programmer, can fix them before your users ever see them. Runtime errors are sometimes hard to track down. So you always, again, want to use strongly typed code. If you make a mistake with strongly typed code that you write, you'll get a compilation error, which is good. All right, so now we've got to change this last little part of code here. We'll use the same technique here, character type .fighter in this case. Whoops, I accidentally deleted that. Okay, so now when we run the example, it should work again. And now we're working with code that's a little more solid than what we worked with previously. All right, so that's one scenario where you are in control of the creation of a new instance of a class. But what if you're accepting data from an end user? then what do you do? Well, in this case, notice that, again, I'm going to point out to the fact that I have this form already created where I'll type in the name of the hero, and then I'm going to allow the user to select one of several predefined options. So let's go ahead and add items to this drop-down list box. And you'll notice that I've already taken the liberty of doing that. I basically just selected the add button and I filled in the text. Here we'll add a thief, and you'll notice that when I do that and hit the tab button on my keyboard, it automatically filled in the value. Now I might do something like this: hi wizard, and then hit the tab key. And I might prefer what the user sees on the user end to be different than the value that I'm storing behind the scenes. So this is what actually will be displayed to the end user. This is an internal value that only the programmer will see, and that will be evaluated by our code. And we'll show you how we'll use this. Now both of these are string values, but we removed this this space here because let's just say that we wanted to add the Hi Wizard option to our enum. Now notice as an enum I also removed the space in between the word hi and wizard. Okay, I don't know what a Hi Wizard is, just made that up. I don't know if there ever has been a Hi Wizard. Okay, so now let's go in and write some code. What we want to do is allow the user to create a new hero, and we want them to be able to select one of the character types from the drop-down list box. Now remember, that's a string, but we're going to need to convert that into an enumeration. How do we do that? Well, how do we do most conversions? We can either do a cast with the opening and closing parentheses, or we would probably expect to see a try parse helper method that would perform that for us. That's the technique we're going to use. So let's go ahead and start by creating a new hero. So var hero equals new character. And then we're going to set the hero's name, to the text box, to the hero name text box dot text. All right, that part's easy. Now the next part, we're going to retrieve the selected value, not the name, but the value property of whatever the selection was by the user. So we're going to use try parse, and we know try parse is going to send an out value, so I'm going to set this up by creating an out. So let's go character type selection, and then if enum, notice the capital E in enum as opposed to the lowercase e when we're defining the enum. So enum dot try parse, and one of the overloads is going to take a string value, which we're going to pass in. That will be the value of the selection from the text box, and then the out, in this case, the selection of type character type. All right, so here we're going to do hero type drop-down list dot selected value, not selected item. That'll give us the item object. We just want the value of that object that was selected. And we need to add the out keyword here, and then I think we're missing a parentheses there, and we should be good to go there. Okay, let me move this over a little bit. Okay, so if we were to find a match, then we're going to be able to set or execute this block of code below. So in this case, what we're going to do is set the hero dot type equal to the selection that was made by the end user. Okay, and then finally, we're just going to copy and paste this exact same code here, and I'll say you selected a fighter, like so. All right, so now let's go ahead and run the application, and let's see what happens. Let's watch the sparks fly. So we'll just call this hero Bob in this case, and we're going to select a wizard, and click the button and nothing happens. But if we were to select fighter and click the button, you selected a fighter. Now what if we choose an option that is not one of our values in the enumeration, like the select one, for example, which is just intended to give a quick instruction to the user visually that they should select one of these items. But what if they leave it here and don't select one? In this case, the code did not fire off. The code for our, unfortunately, for our page load fired off. So let's go ahead and comment that out just for a moment here. Like so. And now let's run the application again. And let's choose Bob, and then we're going to leave it as select one and hit the button and nothing happens. Why? Because try parse was not successful. It could not match up a selected value with one of the preset values in the enumeration, and therefore it did not run this block of code at all, which means that the hero type property is set to null, and this code therefore does not run either. And we might want to do some other, like a gated check right here to make sure that they actually did select one of the items from the drop-down list box. Okay, so that wraps up enumerations. We want to begin using enumerations as often as possible to restrict all possible values to just those that we've defined for that enumeration, that enum data type. And that will help our code be more strongly typed, and as a result of that, we're going to run into fewer runtime errors. We'll get compilation errors if the type we're setting our property to doesn't match one of the predefined values in our enumeration. All right, so stick that in our bag of tricks. We're going to use that for the next project, and let's continue on to the next lesson. Thank you.